All right, we're sitting down, have a little breakfast here. Some Honey Nut Cheerios, some craisins, add some of those in there. All right, so we're looking up essentially like higher dimensions, alternate dimensions, and just trying to get a little data on what it would be like if the universe were tweaked a little bit. So we have, I don't know what happened to the other page. I think the other page was like just basically the question. So this delves right into it. So just get right into it. Electron configuration dictates chemical properties. The arrangement of electrons around the nucleus, which is primarily determined by the number of protons, since neutral atoms have equal protons and electrons, gives elements their characteristic chemical properties. This is why elements in the same column or group of the periodic table behave similarly. Nuclear stability limits. As elements get heavier or with more protons, the electrostatic repulsion between them or between the positively charged protons in the nucleus becomes stronger. The strong nuclear force, which holds the nucleus together, struggles to overcome the repulsion. This is why elements beyond uranium, or Z92, are unstable and radioactive, decaying rapidly. Elements we synthesize in labs, transuranic elements, are extremely short-lived, existing for fractions of a second. There's a theoretical island of stability around higher atomic numbers where elements might be slightly more stable, but they would still be radioactive and short-lived by everyday standards. So, within our universe, the periodic table is quite well defined. We won't find an element between hydrogen and helium with, say, 1.5 protons because protons come in discrete units. We might discover heavier, highly unstable elements beyond oganesson or Z1 element 118, but they would simply extend the existing table. Elements in other universes or multiverse hypotheses. Now let's consider the fascinating realm of the multiverse. Allergies been kicking in so much lately. All right. All right. Where were we? Now let's consider the fascinating realm of the multiverse. The possibility of elements that possesses properties that lie somewhere between or outside the currently understood periodic table becomes genuinely plausible if the fundamental physical laws and constants are different in other universes. All right, let's fuel up. Not sponsored by Honey Nut Cheerios, but Honey Nut Cheerios are good. Go buy some. Strength. Hold on. Oh, here we go. Here's how that could happen. Different fundamental constants. Define structure constant. This constant governs the strength of the electromagnetic force, which binds electrons to nuclei. If the fundamental constant were significantly different, electron orbital structures would change, potentially altering the very concept of shells and how they fill, leading to entirely different chemical behaviors or perhaps even different rules for periodicity. Strength of the strong nuclear force. This force holds protons and neutrons together in the nucleus. If it were weaker, nuclei might only be able to form with very few protons. For example, only hydrogen could exist stably, or even hydrogen might be unstable. If it were significantly stronger, much larger and more stable nuclei could form, leading or extending the periodic table far beyond what we know, or perhaps even collapsing all matter into very heavy elements. Mass of the electron or proton. Changing the masses of these fundamental particles could alter atomic stability and other chemical reactions or chemical interactions. Number of spatial dimensions. Our universe has 3 spatial dimensions plus time. Don't need that no more. Plus time. If another universe had more or fewer dimensions, the laws governing quantum mechanics and particle interactions would be radically different, potentially leading to entirely different ways atoms form, or perhaps even different types of elements that aren't based on proton counts. 2. Different elementary particles. More or fewer types of quarks or leptons. Our protons and neutrons are made of up and down quarks. If other universes had different types or numbers of fundamental particles, the building blocks of matter would be different, leading to completely alien forms of elements. Cool. Existence of exotic atoms. Even within our universe, physicists study exotic atoms where particles other than electrons orbit a nucleus. For example, muonic atoms, where a muon replaces an electron. Allergies acting up. Take some Zyrtec. In other universes, these might be the norm, or entirely new types of stable atoms could exist using different fundamental particles. Different fundamental forces. Imagine a universe with an entirely different set of fundamental forces beyond our four: strong, weak, electromagnetic, and gravity. These forces could mediate interactions that lead to elements with properties utterly unrecognizable to us. Different stability regimes. Even if the fundamental particles are similar, slightly different constants could lead to vastly different islands of stability or entirely different limits on how many protons and neutrons can form a stable nucleus. There might be gaps in the periodic table where certain configurations are unstable, but then stability resumes at higher atomic numbers. There could be elements in between or could there be elements between our current elements? In terms of the number of protons, no, because protons are discrete particles. You can't have half a proton. However, if the very definition of what constitutes an element or how particles combine were different in another universe due to different fundamental laws, then in between states might be conceivable in a way that doesn't map directly to our z equals 1, z equals 2 system. For example, if quarks exist stably as individual entities and directly participate in chemistry without forming protons or neutrons, you could have a whole new kind of periodic system. In essence, if the multiverse allows for variations in the fundamental laws of physics that govern our universe, then the concept of elements and their periodic organization could be radically different. It is a fascinating thought experiment that underscores how our understanding of matter is tied to the specific laws of our own cosmic neighborhood. Right. All right. That was a solid question. And we got some answers. Dope.